Hello everyone, welcome back to Diksha Karnataka YouTube channel, and you are watching PU2 Brahmastra series, where I am going to discuss a semi important chapter, atoms. Okay, the chapter is not super important, but in terms of MCQ obviously all the chapters are important. So as usual we will be solving a lot of MCQ from this chapter as well. Also we will be solving other types of questions that might come from this chapter. So let's start with the weekly schedule. So as you know, Monday was chemistry, today is physics, tomorrow will be biology, and so on. This is the weekly schedule. You can check the chapters, you can check it, and whenever you want to come back to our channel for particular chapter, you can come back. So today we are doing atoms, and on Friday I am be doing the sister chapter, nuclei. Okay, atoms and nuclei are called sister chapters because they are very closely related. Okay, from the chapters atom we know how the nucleus was concept of nucleus was conceived, and then we discuss in detail about nucleus in the nucleus chapter, right? That is the basic concepts. Now if you are currently studying in second PU and wondering about your PU2 final exam preparation, which is very important, not only for your future but also it is important for your qualification of KCET, because as you know KCET exam requires you to get 50% of marks from your PU board exam PCM, right? So here we are bringing you a PU2 success blueprint test series, very important for all PU2 students. It is a paid series, but worry not, we are currently giving you 50% off of 599, and if you use my special code, SAM100, then you will get another 100 rupees off from that, and you will get this only at 499. Okay, if you add my code, you will get one more 100 rupees off. So this is a special Christmas special offer going on, and it is only valid till 28th of December. So don't wait, buy it today, and let me know in the comment below whether you have purchased it or not. It is very helpful for you. Where we are doing what you will get in this series, you will get 12 mock tests. Out of the 12 mock tests, 2 papers are already done. Third paper is going to happen this week. In this 4-part test, so worry not, even if you have not purchased it yet, that you will get the question paper, and you can attempt it on your own and check the answers once you have completed it. Now this 4-part tests actually to prepare you for larger tests. Okay, 4-part test, 25 marks for physics, chemistry, maths and biology. So you will get 4-part tests, 25 mark each from all the subjects, so that your preparation of entire syllabus is over by the time you start full syllabus. Okay, there will be 8 full syllabus tests, 2 for each subject, physics, chemistry, maths, biology or CS. Okay, you will get CS as well in the full test syllabus, right? Full length syllabus. Part test, unfortunately there is no CS as of now. Okay, now let's look into the chapter blueprint of from this chapter. So there we have there is a slight mistake here. What mistake? So in blueprint 1, blueprint 2 and blueprint 3, everywhere you can see 1 mark MCQ is there, right? So all the question paper, all the blueprints are saying that there will be at least one MCQ from this chapter, and this will be remembering based mostly, so it will be easy question. Okay, next in blueprint 1 there is a 3-mark question which is a remembering based 3 marks question, and in blueprint 2 and blueprint 3 they are saying there will be a 2 marks question from this chapter. Okay, so 2 marks question. So the weightage of this chapter is 3 from these 2 blueprints. Okay, now for convenience, what we will do while solving this chapter, we will solve 15 MCQ as usual, and instead of solving 2 marks and 3 marks, we will solve 5 3 marks question. If you study those 5 3 marks question, you can rest assured your chapter will be completed. In case they give you 2 marks question from the chapter, what you have to do, you have to reduce 1 point. I will tell you what to do to convert 3 mark question into 2 mark question. Okay, obviously most of the times a 3 mark question can be asked as a 2 mark question, a 2 mark question can be asked as a 3 marks question. So without any differentiation between them, I will be solving all of them as a 3 mark question, and I will also tell you what to do in case this question was asked as a 2 mark question. Okay, clear? Now So let's start with the MCQ first. When alpha particles are passed through a thin gold foil, most of them go undeviated. So we know that when we pass alpha particles through gold foil kept, most of them go almost undeviated. Why? Because most of the region in an atom is empty space. Alpha particles are positively charged particles, alpha particles are heavier particles, alpha particles move with high energy. So the correct reason is the most space inside the atom is actually empty. That is why it is not colliding with anything and it is going straight. Okay, if you are driving in a empty road, if you are driving your bicycle or your motorcycle in an empty road, you can go straight, right, without worrying too much. But if there is a vehicle coming from the opposite side, or if there is a vehicle standing in front of you, then you have to slow down, you have to take right or left, then you can cross it, right. Similar to that of alpha particle, they are driving on a highway, okay, and the most of the highway is empty, so that they can go up to high speeds and they can go without any deviation, right. Next question, the minimum energy required to free electron from the ground state of the hydrogen atom is minimum energy required to free the electron from the ground state. Ground state means we know that the energy of the ground state is basically En is given by minus 13.6 divided by n square eV. This is the normal formula. Now for ground state n equals to 1. So the energy of ground state is equals to minus 13.6 eV, right. Now to free it, to make it free, what we have to do, we have to make this energy to be equals to 0. So how much additional energy you have to give? You have to give additional energy of the E supplied should be equals to plus 13.6. right. So minus 13.6 is the energy, negative energy implies that it is attached to the nucleus, okay, the nucleus attracting the electron towards it. So that is why the force sign is negative, and this positive energy signifies you are supplying it to the electron so that it can come out of the that attraction. So basically 13.6 electron volt is the amount of energy required to free it. Next question, for an electron revolving around the nucleus, okay, what of the possible cases are true? Let us see. Kinetic energy and potential energy are positive, total energy is negative. Okay, kinetic energy is positive, potential energy and total energy are negative. Potential energy is negative, kinetic energy and total energy are positive. Kinetic energy and potential energy are negative, total energy is positive. Now as we have seen just in our previous problem, the total energy is basically obviously negative, right. Total energy of an orbiting electron around a nucleus is obviously negative, because this is being attracted by the nucleus, it is being bound to the nucleus. The negative sign signifies it is bound to the nucleus. Now we also know that kinetic energy can never be a negative quantity. Kinetic energy is basically a half mv square, m is positive, v even though v can be negative, if you square it, it will always give you a positive value, right. So half mv square can never be negative, so kinetic energy is always positive. Now total energy is basically kinetic energy plus potential energy, okay. Kinetic energy plus potential energy is the total energy. Now total energy is negative, this is positive, so this has to be negative, so that the total value becomes negative, right. So this is the logic that you have to apply, that okay, kinetic energy can never be negative, so kinetic energy has to be positive, so potential energy and total energy has to be negative. So kinetic energy is positive, potential energy and total energy are negative. Even though you do not know anything about nucleus, you still can answer that. Only thing that you need to know is the total energy of a nucleus is negative. So if you know that fact, then you can use the logic and you can calculate, okay, if total energy is negative, potential energy has to be negative, there is no other way. Now let us see this question, the impact parameter is minimum in alpha particle scattering experiment for the scattering angle of. So what is the meaning of impact parameter? Impact parameter means when suppose this is an alpha particle, suppose this is an atom, okay, and a nucleus of the atom, and alpha particle is going towards it. the closest distance it can approach a nucleus is called the impact parameter. Okay, the closest distance, the distance from which it is the closest to the nucleus is called impact parameter, and impact parameter is minimum, means when it reaches the closest possible distance, and this is happening when it is going straight towards the nucleus, and after reaching there, after colliding with the nucleus, it coming back exactly opposite direction. In that case, the scattering angle will be 180 degrees. So, it is going in this direction and it is returning in this direction. So, in that case the angle is 180 degrees, right. So, impact parameter is minimum for angle 180 degree. Okay. Now, next question, Bohr's atomic model cannot explain what of the following cannot be explained using Bohr's atomic model. Spectral line can be explained using Bohr's law. Stability of atom, obviously Bohr's atomic model comes into the picture because of the Rutherford model was not able to explain the stability. So, Bohr's atomic model can definitely explain the stability. Fine structure of spectral line, yes, fine structure of spectral line cannot be explained using Bohr's law. Bohr's law can only explain the overall structure of the spectral line, but if the spectral line is splitting in between, that splitting is not been able to explain by the Bohr's law. If you study physics or if you study chemistry in future, you will study more in detail about this fine structure splitting. Okay, right now you should remember that normally the Balmer series, Paschen series, you have learned that, right. Those are the lines, those are the spectral lines, but under certain condition this one single line can be split into multiple lines. This is called fine structure. So, from one spectral line you are getting more than one lines, okay, under certain conditions. Okay, we will see that in a while, a small brief introduction to that, but that is called fine structure. Okay, or fine structure spectral lines, fine structure splitting, that is not been able to explain by the Bohr's atomic model. So, definitely this is the correct answer for this question. Okay. Next question, the ratio of radii of the first 3 Bohr orbit is. So, ratio of Bohr orbit, Bohr orbit is basically the radius, okay, of nth orbit, and it is proportional to the n square. The only thing that you have to need to remember is the Bohr orbit is the radius of the Bohr's orbit is proportional to n square. So, what is R1? R1 is basically say k into 1 square, that is k, right. R2 is equal to k into 2 square, that is 4k. This is k. And R3, the first 3 Bohr orbit, right. They have said first 3 Bohr's orbit. So, k is the proportionality constant, 3 square, that is 9k. Now, take the ratio. If you take the ratio R1 is to R2 is to R3, it will be 1 is to 1 is to 4 is to 1 is to 4 is to 9, right. So, 1 is to 4 is to 9 is the answer. Okay. Next question, at the distance of closest approach of the alpha particle with gold nucleus, both kinetic energy and potential energy are equal. So, when the now again it is related to the closest approach, distance of closest approach. Okay, when it reaches the closest distance, what happens at this point when it is exactly almost reaching the nucleus? At this point, what happens to the alpha particle? Okay, the entire kinetic energy is converted into potential energy, entire potential energy is converted into kinetic energy, both kinetic energy and potential energy are 0. So, when it is exactly at this point, it is momentarily stopped. Okay, when it is reaching to the closest point to the nucleus, its momentarily speed is 0. Momentarily speed 0 means its entire potential energy is now entire kinetic energy is now converted into potential energy. Remember that total energy is conserved in this case as well. So, entire kinetic energy is converted into potential energy, that is the answer. Now, let us move on to the next question. Which of the following spectral series of hydrogen atom is lying in the visible range of the electromagnetic wave? This is the most easy question. Okay, what is that? I told you, if you have seen my KCET series or any other series related to this chapter atom, I have said Balmer series is the series which falls in the visible region. Okay, all other series are either in the ultraviolet region or they are in the infrared region. They cannot be seen. Only Balmer series, 3 lines for specifically from Balmer series can be seen in the visible region. Visible region means the wavelength range where we can see using our normal eye. So, that is the Balmer series. Next question, the scientist who credited with the discovery of nucleus in an atom. So, who is the person who discovered the nucleus, credited with the, okay, maybe you think Niels Bohr, but the actual answer is Rutherford. Okay, Rutherford, before Rutherford no one actually knew there is a nucleus. Okay, J.J. Thomson discovered the electrons, okay, and then he proposed that because materials appear solid, okay, so there must be it should be like a cake, atom should be like a cake, and on top of cake, if you are Christmas enthusiast or if you eat cakes, you know there is a called plum cake which is very popular during Christmas, where you get raisins, nuts, etc. are embedded in the plum, right. So, this is a plum cake. So, he said plum pudding model, okay, and these are the puddings, okay. Plum is the cake. So, this is the plum, entire shape of the atom is like the plum, and all the electrons are embedded inside it like a pudding, right. But later on, so to test that whether it is correct or not, Rutherford devised an experiment who was actually a student of Thomson, okay. So, Rutherford was a student of Thomson and Bohr was student of Rutherford. So, they have a very nice student teacher relationship. So, in future I hope some of you will come and teach physics in my place, and they will be a better teacher than me, right. So, this is how the scientific journey continued. So, Thomson first discovered the idea of atom, okay. He said obviously atom concept of atom was known since Dalton, since the time of Dalton, but what is the nature of the atom was not known at that point of time. It was indivisible, okay, smallest particle, like that was the postulates given by Dalton, right. So, those were prevalent at this point of time also, but Thomson discovered electron and he said okay, electrons are negative, but atom is obviously neutral in nature. So, basically there has to be something positive, base of the atom should be positive and electrons are embedded in it, right. It was his first model. This is called plum pudding model, Thomson's atomic model. Then Rutherford tested it and he found that atom is not solid at all. Most of the space inside the atom is empty, right. From there he said okay, there must be something hugely positive thing which is located at the center of the atom, okay, and that hugely positive center he termed it as nucleus. That is why the discovery of nucleus was given to Rutherford, but at this point of time also the exact nature of nucleus was not known, whether it is only a single positive particle or it is constituting of multiple protons and neutrons. That was not known at this point of time. Only he suggested that there is a huge positive chunk which is sitting at the center of the atom and all the electrons are orbiting around it. That is what his theory. Next question, when white light passes through a gas and we analyze the transmitted light using a spectrometer, we find some dark lines in the spectrum. These dark lines are called emission spectrum, absorption spectrum, missing line, dark band. They are called absorption spectrum. So, absorption spectrum are those when you allow light to pass through a material, okay. Those material actually absorb certain spectral lines. In case if you excite them, if you make them hot, then at that point of time they will emit the exact same spectrum, okay. So, absorption spectrum and emission spectrum are twin brothers, but there is a catch. One is positive, another one is negative. So, one is giving light, another one is absorbing light. So, that is what yin and yang concept came in the existence, right. Now, the lowest state of the atom is called lower orbit, ground state, earth state, none of the above. We know the lower most possible energy state is called ground state. Next question, the radius of nth Bohr orbit is proportional to, we already solved one such question, the ratio of radius of nth Bohr orbit is proportional to n square, Rn is proportional to n square, right, not equals to, sorry, proportional to. That is enough information for your PU board. Okay, you do not need to remember the entire expression for it, right. Next question, the total energy of the electron orbiting a hydrogen nucleus is negative. This implies the fact that the electron is free to move, electron repels the nucleus, electron is bound to the nucleus, all of the above. So, basic answer is electron is bound to the nucleus. Okay, because electron is bound to the nucleus or electron is getting attracted by the nucleus, that is why its energy is negative. Negative energy means it is bound. Okay, it owes some amount, some due. Okay, so basically when you take loan from something, you are bound to them. Okay, so you asked your friend, hey, give me 10 rupees, no, I will return you next week. So whenever your friend says, okay, give me the money back, give me the money back, so basically you are bound to him, right. So basically the electron owes money to the nucleus. So if you supply that energy outside, from outside, then it will come out, become a free electron, right. Now in a Bohr atom, an electron emits energy only when it moves from ground state to excited state, it moves from excited state to ground state, always never. So in a Bohr atom, electron emits energy when it is transmitting from higher energy state to ground energy state. Electron absorbs energy when it is moving from ground state to higher energy state. So to go to the higher energy state, it requires energy. Okay, it requires energy to be able to transfer from ground state to higher energy. But when it is jumping from higher energy to lower energy, it emits that extra energy. So that is why that is the source of the spectral line that we observe. So when it moves from excited state to the ground state, it emits the extra energy. The energy of an electron at the ground state of a hydrogen atom is, so energy of an electron in ground state of hydrogen atom is minus 13.6 eV. In this case, what is the energy? We have already seen in our previous two MCQs that it was related to ground state energy. Ground state energy is minus 13.6 eV. If you want to make it free, then you have to supply positive of that, that is 13.6 eV. Okay, but energy of ground state is minus 13.6 eV. Now write 3 postulates of Bohr's atomic model. Now we have switched to 3 marks category. Write 3 postulates of Bohr's atomic model. So let us see one by one. An electron cannot move around the nucleus in all orbits, all possible orbits. So according to Rutherford, electron can move around any orbit. There was no specification, there was no limitation, that is why the law failed, that is why the atomic model failed, because we will learn in a later stage that when electron is accelerating in an electric field, it radiates electromagnetic radiation, okay, electromagnetic waves, right. And if someone is giving away energy, electromagnetic waves definitely require some amount of energy. So when electron is moving in a circle, that is basically it is an accelerating electron. An accelerating electron radiates energy, that energy has to be supplied by the kinetic energy. Conservation of energy is always true. So if that is happening, then the electron should after some time will jump to the nucleus and die. So nucleus will slowly lose away all the charges, because positive and negative will cancel each other, and the atom will be dead in 10 to the power of minus 8 seconds. So universe after creating itself, okay, after Big Bang, within 10 to the power of minus 8 seconds, it would have been completely dead. There would not be possible to form anything else, but somehow that is not happening. That is why Bohr suggested that an electron cannot move around the nucleus in all orbits, it can move only in certain discrete discontinuous orbits. So orbits are not continuous orbits. If one orbit is suppose electron is orbiting like this, and according to Rutherford it can orbit just next to it, but Bohr said no, it cannot orbit any orbit, but it has to be some discrete orbit. Okay, this is one orbit, this is second orbit, third orbit say another height, some like that. Okay, so that was Bohr's postulate. Okay, Next what? The permitted orbit are those in which the regular momentum of the electron is an integral multiple of h by 2 pi. So, regular angular momentum, that is L, equals to nh by 2 pi. Now, L can be written as mvr. So, mvr is equal to nh by 2 pi. That was Bohr's postulate. If they satisfy this relationship, only those orbits are possible. Here n equals to 0, sorry, not 0, n is equal to 1, 2, 3 dot dot dot. Okay, integral multiple means integer multiples. Okay. When the electron moves in these orbits, the energy is not given out. Energy is given out only when an electron from a higher permitted orbit jumps down to a lower permitted orbit. The difference in energies is emitted of the form of radiation, that is E1 minus E2 is equal to h nu. So, they are stable orbits and electron can orbit only around those stable orbits and it is fixed. Okay, and that has to be mvr is equal to nh by 2 pi, does not matter who they are. And he also said when electron cannot emit energy when they are in this stable orbit, they can only emit energy when they are moving between orbits. Okay, so, if they are absorbing energy, it can go to the excited state. When it is coming back to the ground state, it can emit the energy. Okay, only then the electromagnetic radiation is possible, otherwise electromagnetic radiation is not possible. Next what? Write 3 limitations of Bohr's atomic model. So, Bohr's atomic model, as you can see, is very important from this chapter. First we have learned the postulates, Bohr's postulates, very important. You have to write this in proper sentence form. Okay, you cannot simply write mvr is equal to nh by 2 pi. What is the meaning of that? You have to write it in proper words, proper sentences, explain it to get the full marks. Okay, I have seen students, even though they know the answer, they are too lazy to write the complete answer. So, if you are the person who is too lazy to write the answer, then definitely you will lose out on marks. Next question, let us see the 3 limitations. The Bohr model is applicable to hydrogenic atoms. Hydrogenic atom means which has only one proton at the nucleus. Okay. We will learn about the nucleus obviously in our next chapter, but for now you should know that hydrogenic atom means only one proton in the nucleus. Okay. There may be some other isotopes. We know that there are 3 isotopes of hydrogen, that is deuterium and tritium. So, for those cases only this is applicable. Okay, only one electron and one proton, if that is the constituent, then you can apply Bohr's model, otherwise you cannot apply Bohr's model. But what was suppose for example, why this Bohr model we are studying, then it is only applicable to hydrogen atom, why we are studying it at all, why it is important? Because first of all you should realize that Rutherford's model was not even been able to explain anything, whereas Bohr's model at least elevated to one stage. Now, it can explain at least the hydrogen atom, the most fundamental particle, most light particle, first element of the atomic table. So, it can explain hydrogen. That means, if we can improve on this form, if we can study it harder and if we can make the correction, required correction, then definitely Bohr's model can be applicable to modified Bohr's model can be applicable to all other atoms. That is how the science grows. So, you give a theory. Okay, you test this theory out if it is correct or not, and if it is found to be incorrect, then you give another theory. Okay, why it is you test on the basis and then you say, okay, this basis is not matching. So, definitely this is not correct and possible explanation is this. So, after that possible explanation, you have to check the possible explanation itself whether the explanation makes any sense or not. Okay, if it is making any sense, from there you have to develop, okay, this is applicable to only hydrogen. Now, let us see why it is not been applicable to the next atom, helium. So, then from there on you develop slowly you develop and you find out, okay, this is the correction that we need to do. So, the atomic theory that we currently study, mostly some part in chemistry we study, okay, the hybridization model, etc., that is basically coming from this Bohr's basic model. Okay. While the Bohr's model correctly predicts the frequencies of the light emitted by the hydrogenic atoms, the model is unable to explain the relative intensities of the frequencies of the spectrum. So, relative intensity in the sense, according to Bohr's model, all the spectral lines we see should have the same intensity. Okay, they should be equally bright. But while you observe the emission spectrum, you see some of the lines are super bright, whereas some of the lines are very dim. So, this relative intensity was not been able to explain by the Bohr's model. Okay, this is high level of quantum mechanics. The model does not explain the fine structure and splitting of spectrum spectral lines observed under a magnetic field, Zeeman effect, or an electric field, that is Stark effect. So, as I said in while discussing one of the MCQs, that lines split into multiple lines, one line split into multiple lines. So, that splitting one of the splitting effect is called Zeeman effect, another one is called Stark effect. So, in another application of external magnetic field and electric field, the line splits into multiple lines, that is called Stark effect and Zeeman effect, which was not been able to explain by the Bohr's model. Bohr's model is very simple, simplistic model. Only thing that he did, he said okay, atoms are orbiting in a static orbit and they have to obey mvr is equal to LH by 2 pi, and electron can emit energy only when they are jumping, that is it. So, that is the only basic 3 postulates of Bohr's model, and they cannot be able to explain all these complex theories. For that you need a complex model, right. How is the total energy of an electron revolving in an orbit of hydrogen atom related to the principal quantum number of the orbit? What is the significance of the negative sign in the expression of the total energy of the electron in an hydrogen atom? So, let us see, the energy is given by minus 13.6 n by n square. The negative sign, as we have learned already, negative sign indicates the electron is bound to the nucleus, right. And here you have to mention n equals to principal quantum number. So, quantum mechanics or quantum physics actually born from here onwards. Okay, he gave the principal quantum number. Later on we learned there are not only one quantum number, there are multiple quantum numbers, right. You have learned in the chemistry chapter that there are hybridization process, there are multiple quantum numbers, right. So, based on that, even there are more quantum numbers than you know right now. Okay, you will study in future if you study physics or chemistry. So, those are basically the facts which prevented Bohr to elevate this model to the next stage, but it came and it obviously revolutionized the entire physics. Now, give the de Broglie's explanation of Bohr's second postulate of quantization of angular momentum. This question is I think from one of your previous year question, or this question is from one of your model question paper, I think previous year question. Okay. So, here this diagram, if you can draw it, very good. As you can see, one wave is from the down, another wave is from the top. So, what is this? This is called, if you remember, one wave like this, another wave like this, like a spectacles, okay, Batman spectacles. This is basically standing wave. So, when two waves cancel each other, they are forming standing waves. So, de Broglie said that de Broglie proposed that the electrons exhibit wave like properties and their motion in a orbit can be described as a standing wave. So, very important thing, de Broglie said electrons while moving in the orbit, they are not behaving like a particle, but they are behaving like a standing wave. Okay. And for the electrons wave to form a standing wave around the nucleus, the circumference of the orbit must be an integral multiple of the electrons wavelength 2 pi r n equals to n lambda. Okay. In fact, from here you can prove that the Bohr's postulate. So, let me do that because I have some time. So, let me do that. 2 pi r n, that was de Broglie's explanation, that this n should be integral multiple of wavelength of the wavelength. So, wavelength is basically given by two consecutive lines, nodes, right. So, this is the not two consecutive, between 1, 2, 3, between 3 nodes, whatever the distance is, that is the wavelength, right. Now, 2 pi r n is equal to n lambda. Now, from de Broglie's hypothesis himself, we know that lambda is basically h by p, okay, or we can say 2 pi r n times p equals to n h, okay, or r n. What is p? P is basically momentum. Momentum is m times v, that is equals to n h by 2 pi, right. So, this is the Bohr's postulate that MVR should be, angular momentum should be integral multiple of h by 2 pi. So, n h by 2 pi, n is already automatically coming here, h by 2 pi is also coming from de Broglie's wavelength. So, he postulated that basically electrons are behaving like a standing wave, okay, and he also gave the idea about the orbit of or wavelength of that static wave. So, this is how the science grows. Next question, mention 3 drawbacks of Rutherford's atomic model. This question used to be popular in the past, okay. Nowadays I have not seen any Rutherford related questions, okay. Maybe Rutherford's observation, but that is also not very common, okay, but in your college exams or your pre-board exams this question might come. So, you have a need to have a look at this question as well. So, what are the drawbacks of Rutherford's model? Fails to explain the stability of atom. So, Rutherford's model, as I explained, is not able to explain the stability of atom. No explanation for atomic spectra. So, atomic spectra cannot be at all be explained by Rutherford's model. Does not address electron arrangement. So, electrons, how the electrons are arranged inside a nucleus, because we know that many atoms have multiple electrons. How they are arranged inside the atom was not been able to explain by the Rutherford. So, these are the main 3 drawbacks of Rutherford's model, okay. Now, again I am here to tell you about our very important test series, PU2 success blueprint test series, where we are offering you 4 part tests and 8 full syllabus tests, okay. The subjects cover PCM and computer science as well. You will get full exam focused question papers with their PDF solutions. Also, you will get video solutions of the question paper, okay, and you will get in doubt clarification session, and all of this is for 599. But if you apply my special code SAM100, you will get another 100 rupees off on top of that. That is 499 only, and that is only valid till 28th of December. So, I am giving you 100 rupees extra as your Santa. So, you can apply this code while purchasing this, you will get extra 100 rupees offer, right. So, this is very limited time offer, Christmas special. So, do not forget to apply this code before you purchase, and the link of this is given in the description, right. So, I will be back with the chapter nucleus on Friday. Till then, bye and Merry Christmas.